Good evening, students. I'm your physics teacher Vikal, and today we are going to discuss about specific heat capacity. Okay, so yesterday we have seen internal energy, heat, work, and first law of thermodynamics. Okay, now we will move forward with specific heat capacity. तो पहले समझते हैं हम लोग हीट कैपेसिटी क्या होती है. What is heat capacity? Then we will move to specific heat capacity. Okay, so first we will see heat capacity. Heat capacity. Okay, so नाम से हम लोग समझ सकते हैं, जैसा कि हीट कैपेसिटी मतलब किसी भी सब्सटेंस में कितनी कैपेसिटी है उस हीट को स्टोर करने की. ठीक है, हम लोग नाम से ही समझते हैं. ओके, बट व्हाट इज हीट कैपेसिटी? इफ we supply a delta Q heat, delta Q heat supplied to a substance, then what happen? Then what happen? It changes its temperature from T to T plus delta T. Okay, if we just assume we are giving a heat delta Q to a substance, then what happens? Substance temperature changes from T to T plus delta T. That means what is the change in the temperature? That is delta T. Okay, so we can define then heat capacity is defined as, we denote heat capacity by S, capital S. Okay, and it is defined as how much heat is supplied to the substance divided by how much temperature changed. Okay, heat supplied divided by change in the temperature of the substance. Okay, so that is heat capacity, and its formula is delta Q by delta T. Its unit is joule per Kelvin. Joule is the unit of heat and Kelvin is the unit of temperature. So its unit is joule per Kelvin. Okay, but we can say this heat capacity is dependent on mass of the substance. फर्स्ट ऑफ ऑल फिजिकली समझते हैं हम लोग होता क्या है हीट कैपेसिटी. ठीक है, सो we have different material, different metals, different substances. So if we give a particular amount of heat to different substances, to different materials, then what happens? For different substances there will be time taken to raise the temperature. Good evening Anand. Okay, तो अगर हम लोग कोई एक पर्टिकुलर अमाउंट ऑफ हीट देते हैं किसी सब्सटेंस को, तो उसका टेम्परेचर बढ़ेगा. अगर मान लो 1 डिग्री सेल्सियस टेम्परेचर बढ़ाने के लिए किसी भी सब्सटेंस का, लाइक वी कैन से एल्यूमिनियम. ओके, अगर हमने एल्यूमिनियम को कोई एक हीट दी, पर्टिकुलर अमाउंट ऑफ हीट दी, तो उसका एक डिग्री सेल्सियस बढ़ाने के लिए कुछ टाइम लगेगा. ठीक है, एंड सेम हीट वी हैव गिवन टू डिफरेंट सब्सटेंस, लाइक वी कैन से वाटर. देन विल time taken to increase the temperature by 1 degree Celsius for both water and aluminium be same? No. वाटर का टेम्परेचर 1 डिग्री सेल्सियस बढ़ाने के लिए टाइम कुछ और होगा, और एल्यूमिनियम का कुछ टेम्परेचर बढ़ाने के लिए 1 डिग्री सेल्सियस उसके लिए टाइम कुछ और होगा. मतलब दोनों का जो टाइम टेकन होगा 1 डिग्री सेल्सियस टेम्परेचर बढ़ाने के लिए, दैट विल बी डिफरेंट. व्हाई? बिकॉज that heat capacity is different for both material. Heat capacity is different for both material. So that's why we are defining heat capacity. How much heat we have given to raise the temperature by delta T. Okay. Okay. So this heat capacity is dependent on mass. Like simple. If we have a small piece of the aluminum, we are giving heat to it, then its temperature will rise fast. If we have a massive block of the aluminum and we are giving heat to that massive block of aluminum, then its temperature will increase slowly. Okay, so that means this heat capacity is dependent on mass. Okay. Yeah, we are seeing this topic here, specific heat capacity today. Then we will see like state variables and equation of state. Okay, so this heat capacity is dependent on mass of the substance, but we want a quantity which is independent of mass, or we can say which is independent of amount of substance, which will be same for like any mass. Okay, then what we'll do, we'll just divide mass by this. Okay, so if we will divide mass by this S by M, then what we will get? We will get small s. Small s equal to capital S divided by mass, and it is equal to 1 by M. What is S? Delta Q by delta T. Delta Q by delta T. And this small s is known as specific heat capacity. Specific heat capacity. Now this is a constant value for any material, any substance. Like for a fixed substance, like for water, its value will be fixed. Okay, its value will be fixed for water. Specific heat capacity, that is 4.18. 4.18. So what is the unit? Unit will be, here it is joule per Kelvin. Joule per Kelvin. Here we have divided mass, so it will become joule per kg Kelvin. This will be the unit of specific heat capacity. I hope all of you understood. Okay, so it is dependent on what? What factor it is dependent? So specific heat capacity is dependent on. It is dependent. Specific heat capacity is dependent on what? It is dependent on nature of substance and temperature. Okay, so it is dependent on nature of substance. Like for different substance, this will be different. So nature of substance and its temperature. Okay. So specific heat capacity is dependent on nature of substance and its temperature. But heat capacity was dependent on its mass also. So that's why we changed the formula. We got a different quantity, some separate quantity, that is called as specific heat capacity. Okay. So specific heat capacity is dependent on only nature of substance. Like for aluminum it will be different, for copper it will be different. Okay, so nature of substance and its temperature. Okay, I hope you understood. Okay, so here we have taken amount of substance as mass. Amount of substance as mass. Okay, if amount of substance is given in terms of mole, then we define heat capacity per mole. See there, if substance, amount of substance is given in terms of mass, then we defined heat capacity per mass, per unit mass, and that was called as specific heat capacity. Okay, but अगर amount of substance हमको moles के term में दिया हुआ है, तो हम लोग कैसे define करेंगे? Heat capacity per mole. Heat capacity per mole. Okay, so we denote it by capital C, and that is equal to what? That is, heat capacity is what? delta Q by delta T, delta Q by delta T, and heat capacity per mole. Per mole means moles का भी divide कर दो, mu moles. Okay, so it became molar specific heat capacity. Hi Sasanka. Okay, so C is what it is. It is called as molar specific heat capacity. Good evening, good evening, good evening. Okay, so its unit will be what? Delta Q by delta T का unit क्या था? Joule per Kelvin. Okay, here 1 by mu is also coming. So it will become Joule per mole Kelvin. Understood? So that is what? That is molar specific heat capacity. So it is dependent on what? So it depends. देखो specific heat capacity, हाँ, जब हम लोग को मास दिया हो, सब्सटेंस, अमाउंट ऑफ सब्सटेंस मास के टर्म में दिया हो. मोलर स्पेसिफिक हीट कैपेसिटी जब हम लोग को अमाउंट ऑफ सब्सटेंस मोल्स के टर्म में दिया हो. ठीक है, तो ज्यादातर हम लोग को अमाउंट ऑफ सब्सटेंस मोल्स के टर्म में कब दिया होता है? जब गैसेस से डील करते हैं हम लोग. ओके, सो व्हेन वी डील विद द गैसेस at that time amount of substance is given in terms of moles. When we deal with solids, at that time amount of substance is given in terms of mass. Okay. So molar specific heat capacity is dependent on what? It depends on nature of substance. Simple. Nature of substance. Like for oxygen gas it will be different, its value will be different. For nitrogen it will be different. Okay, for different gases the value of molar specific heat capacity will be different. So it depends on the nature of substance, its temperature, and one more thing, process by which heat is supplied to the substance. Okay. So it is dependent on what? Nature of substance, its temperature, and process. It is dependent on process also. By what process we are supplying heat? Okay, so if we are supplying heat by different process, then molar specific heat will change for that gas. Okay, that we will see. So understood what is molar specific heat capacity and what is specific heat capacity. Specific heat capacity is per unit mass, and molar specific heat capacity is what? Per unit moles. Okay. I hope all of you understood. So I'm writing some values of specific heat capacity. Like for aluminium, value of specific heat capacity is 900 joule per kg Kelvin. And for copper its value is 386 joule per kg Kelvin. For water specific heat capacity value is 4186 joule per kg Kelvin. Okay, so I think its table is given in the NCERT book also. Table of specific heat capacity for different substances. Okay, that you can see. No need to remember all the values. Only for water you can remember. For water, value of specific heat capacity you can remember. That is 4186 joule per kg Kelvin. Okay. Okay. Now, specific. Wait. Specific heat capacity of water. Why are we talking about specific heat capacity of water separately? Because earlier historically we used calorie unit for heat. To measure the heat we have used calorie as the unit. Okay, so calorie was an old unit of heat. Okay, so that calorie unit is we can say is dependent on, or we can say is that calorie unit, how to convert that calorie unit in joules. It is dependent on specific heat capacity of water. So how we define 1 calorie? 1 calorie is equals to what? Heat required, heat required to raise the temperature of 1 gram of water by 1 degree Celsius. अगर हम लोग वाटर को 1 ग्राम वाटर को 1 कैलोरी हीट देते हैं तो उसका 1 डिग्री सेल्सियस टेम्परेचर राइज होता है. Okay, heat required to raise the temperature of 1 gram of H2O by 1 degree Celsius. Okay, so that heat was what? That heat was 4.186 joule per gram Kelvin, or we can write 4186 joule per kg Kelvin. Okay, so this much heat is required. 4.186 joule per gram Kelvin or 4186 joule per kg Kelvin. This much heat is required to raise the temperature of 1 gram of water by 1 degree Celsius. अगर 1 डिग्री सेल्सियस टेम्परेचर बढ़ाना है 1 ग्राम वाटर का, तो इतनी हीट हम लोग को देनी पड़ेगी. So you can see this is very high value in comparison of specific heat of aluminum and copper. So you can see that's why we use water as the coolant in power plants, in different like industries. We use water as the coolant. Why? Because water's temperature increases by storing so much energy. Like you can see, if water stores 4186 joule of energy, joule of heat, then what happens? Its temperature rise by 1 degree Celsius. You can see this is so much heat. But for aluminum, it was 900. It was 900 joule per kg Kelvin. That means this was for aluminum. Okay, so for aluminum, it was 900. That means if you will give 900 joule of energy, joule of heat to aluminum, then its temperature rise by 1 degree Celsius. But to water, you have to give this much heat. That means we can use water as the coolant. क्योंकि water का temperature इतना जल्दी नहीं बढ़ेगा, but aluminum बढ़ जाएगा. You can see aluminum का बर्तन हम लोग किचन में यूज करते हैं. You can see when we use any utensil of aluminum, in few seconds it become hot. But to boil the water, we need much more energy, much more heat. Understood? So that's why we use water as the coolant. And why specific heat of capacity of water is important? Because it is related with calorie. Specific heat capacity of water is equals to 1 calorie. Okay, and calorie was an old unit of heat. In earlier days, we used calorie as unit of heat. Okay. Okay. Now, as we have seen, specific heat capacity is dependent on process also. It depends on process by which heat is supplied. So for different process, specific heat capacity will be different. Understood? So for gases, we can define two specific heat capacity. heat capacity. So what first one is we define specific heat capacity at constant volume, and second one is specific heat capacity at constant pressure. See, जैसा कि मैंने बताया, as I told you, specific heat capacity is dependent on nature of substance, on the process also, like from by which process we are giving heat to the substance. If we will change the process, then specific heat capacity will also change. Okay, so for gases, we know we can heat a gas by several ways of process, like through several process, like by keeping pressure constant, by keeping volume constant. Okay, so for different process, specific heat will be different. Simple. So for gases, we define specific heat capacity in two ways. First one is specific heat capacity at constant pressure, at constant volume, and second is specific heat capacity at constant pressure. Okay. Okay. Now we will see an important relation. For ideal gas. For an ideal gas, we know a relation that is Cp minus Cv equals to R. Cp minus Cv equals to R. Okay, and now we are going to prove this relation. First of all, we have to know what is Cp. Cp is molar specific heat capacity at constant pressure. Okay, and Cv is what? Cv is molar specific heat capacity at constant volume. Okay, and what is R? R is universal gas constant. Okay, ठीक है? And its value is 8.314 joule per mole Kelvin. It's a constant, universal gas constant. Okay, now we have to prove this equation for an ideal gas, that is a relation between Cp and Cv. Cp minus Cv is equals to R. The difference of molar specific heat capacity at constant pressure and constant volume is equals to universal gas constant, and that we are going to prove. Okay. Okay. So Cp we can write. How can we write Cp? As we know, we defined molar specific heat capacity as 1 by mu delta Q by delta T. So here I am writing dQ by dt. dQ by dt. If this molar specific heat capacity is at constant pressure, then we can write as Cp, and this we can write as dQ by dt as P. Okay. Similarly, Cv we can write like 1 by mu dQ by dt at constant volume. Simple. Here what are we doing? Here we are supplying heat at constant pressure, and here we are supplying heat at constant volume. As I told you, specific heat capacity is dependent on process by which we are supplying heat to the substance. ठीक है, तो इधर हमारा जो प्रोसेस है वो है कांस्टेंट प्रेशर, ठीक है, एंड हियर हमारा प्रोसेस है कांस्टेंट वॉल्यूम. हियर वी आर सप्लाइंग हीट एट कांस्टेंट वॉल्यूम. ठीक है. ओके, नाउ वी आर गोइंग टू प्रूव दिस रिलेशन. ठीक है. सो first of all, we will write first law of thermodynamics. What was first law of thermodynamics? First law of thermodynamics is first law of thermodynamics. It says dq equal to du plus dw. dq equal to du plus dw, and dw we already know what is the form. What is the dw? We have already seen work done by the gas. dq equal to du plus pdv. We can write as dw as pdv. Okay. Now at constant pressure, sorry, at constant volume. First we will see at constant volume. At constant volume. At constant volume, we know dv equals to 0. At constant volume, dv equals to 0. So we can put this term as 0. Because dv is 0, change in volume is 0. So this work done will also become 0. Put dv equal to 0 here, and this term will become 0. This term will become 0. So we can write as dq equal to du. Okay. So this is constant volume process. And we know at constant volume, we can write dq equal to what? Mu cv dt. Okay. So from here, we can write dq in place of dq, we can write as, see, from here we can write as dq equal to mu cv dt, and this dq we will put here. So we can say dq equal to du equal to mu cv dt. Okay, so we got a formula of internal energy, change in internal energy. Change in internal energy here, it is dependent on only change in temperature. And already I told you, when we discussed about internal energy, I told you internal energy is dependent on temperature. Here it is change in internal energy, that is dependent on change in temperature. Okay. Okay. Now we will write first law for constant pressure process at constant pressure. At constant pressure, we know dp will be equal to 0. Change in pressure will be equal to 0. Constant pressure means pressure will not change. Pressure will not change means dp equal to 0. Change in pressure equal to 0. Okay, now write the equation. dq equals to du plus dw. dw is what? pdv. pdv. Okay. Now, from this, because now we are dealing with constant pressure process. Okay, so in constant pressure process, dq equal to what? dq equal to mu cp dt. In constant volume, what was dq? Mu cv dt. Okay, in constant pressure process will be dq equal to what? dq equal to mu cp dt. Okay, so here we'll write mu cp dt, and that is equals to what? du. Already we have seen du is equals to mu cv dt, and it is independent of process. We know internal energy is not dependent on process. Whichever process is there, internal energy, change in internal energy will be same. Okay, so d equal to what? Mu cv dt. Put here mu cv dt plus pdv plus pdv. Okay. Now, as we know, ideal gas equation is what? PV equal to mu RT. Now differentiate this equation. Differentiate. So on differentiating PV equal to mu RT, we will get first PdV and then VdP. Pressure constant, differentiate volume, PdV. Now taking volume constant, differentiate pressure. So VdP is equals to what? Mu R, both are constant, and here it is dt. Now see, we are dealing with constant pressure process. So dp is equals to 0. So here dp equals to 0. Now pdv equal to what? Mu R dt. pdv equal to what? Mu R dt. As we know, this is first equation. So substituting in equation 1. Okay, so pdv की value mu R dt put करो इधर first equation में. So we'll get mu cp dt equal to mu cv dt equal to what? Sorry, will come plus. हाँ, plus pdv की value क्या होगी? Mu R dt. So mu R dt. See, mu cancel, dt dt dt. cancel, and here it is remaining what? Cp equal to Cv minus R. So we can write as Cp minus Cv equal to R, and we have proved this relation Cp minus Cv equal to R. Understood? So it is known as Mayer's relation. M-A-Y-E-R, Mayer's relation. Okay, so this is one relation, Cp minus Cv equal to R. One more relation is there between Cp and Cv, that is as Cp divided by Cv. Ratio of Cp and Cv is known as gamma, and that gamma is what? Adiabatic constant. Adiabatic constant. We will see this gamma in types of process when we will discuss about adiabatic process. That time we will see gamma. Okay, for now you have to remember ratio of Cp and Cv is what? Gamma. Okay. So from here we can define Cp and Cv. How? If Cp by Cv equals to gamma, so from here we can write as Cp equals to gamma Cv, and put this Cp here. Put this value of Cp in this equation. So what we will get? We will get as gamma Cv minus Cv equals to R. Take Cv as common. So Cv अगर common लिया हम लोगों ने तो यहाँ से क्या आ जाएगा? R divided by gamma minus 1. एक और फॉर्मूला आ गया Cv का. Cv equals to R divided by gamma minus 1. गामा हम लोग को डिफरेंट गैसेस के लिए गामा की वैल्यू डिफरेंट होगी, वो हम लोग देखेंगे जब एडियाबेटिक प्रोसेस हम लोग पढ़ेंगे. ठीक है. So Cv equals to R by gamma minus 1. Similarly Cp. अब अगर हम लोग दिस वैल्यू अगर पुट करेंगे यहाँ पे Cv की जगह, तो हम लोग को Cp भी मिल जाएगा, एंड दैट Cp विल बी इक्वल्स टू, आई एम राइटिंग हियर, Cp विल बी इक्वल टू गामा R डिवाइड बाय गामा माइनस 1. Okay, so here some formula, you have to remember only two formula, Cp minus Cv equals to R and Cp by Cv equals to gamma. ये फॉर्मूला और ये फॉर्मूला तो हम लोग ने डिराइव करके निकाल लिया. कैसे? Cp by Cv equals to gamma. So from here Cp equals to gamma Cv, और ये वैल्यू हम लोग को ये पुट करनी इस वाली इक्वेशन में, और उसके बाद कॉमन लेके Cv कॉमन लेके हमको मिल जाएगा ये R by gamma minus 1. Okay, I hope all of you understood. Remember these relations, this relation and this relation, important relation. Okay. Now we will solve this problem which was asked in Mains 2010. Mains 2010. Okay. So what is given? If Cp, here it is given small Cp. Cp and Cv denote the specific heats per unit mass of an ideal gas of molecular weight m. Okay. As we already know by Mayer's relation, capital Cp minus capital Cv equals to what? R. We know this relation. Okay. Now, this is molar specific heat capacity. Molar specific heat capacity. And that we can write as like Cp equals to 1 by mu delta Q by delta T at constant pressure, and Cv equals to what? 1 by mu delta Q by delta T at constant volume. Okay. Now, if you will see, this delta Q by delta T is what? Delta Q by delta T is simple specific heat, not molar specific heat, only specific. Simple, we can say like heat capacity. Heat capacity. Okay. So we are denoting it by small Cp. This dq by dt as small Cp and dq by dt here as small Cv. Okay. So from here we can write small Cp is equals to what? Small Cp is equals to mu capital Cp, and here small Cv equals to what? Mu capital Cv. Okay. And we know number of moles equals to mass upon molar mass or molecular weight. तो हम लोग यहाँ पे इसको कैसे लिख सकते हैं, स्मॉल मास डिवाइड बाय कैपिटल मास. कैपिटल मास मीन्स मोलर मास इनटू सीपी. ओके, वेट अ मिनट, here I have to put equal. Okay, and this we can write as mass upon molar mass into CV. As we know, here it is given as unit mass. Unit mass means जो small m की वैल्यू होगी हम लोग 1 पुट कर देंगे, and that capital M, that is molar mass, we will multiply here. Will multiply here. तो अब ये क्या आ जाएगा, as small m is equals to 1 kg is given, unit मास दिया हुआ है हम लोग को, यूनिट मास दिया हुआ है, यू कैन सी. ओके, सो 1 पुट किया तो यहाँ पे क्या हो गया, हम लोग को मिलेगा कैपिटल सीपी इक्वल्स टू एम इंटू स्मॉल सीपी एंड कैपिटल सीवी इक्वल्स टू एम इंटू स्मॉल सीवी. अब ये वैल्यू और ये वैल्यू पुट करो इधर इस इक्वेशन में. ओके, सो फ्रॉम इक्वेशन 1 हम लोग लिखेंगे कैपिटल M इंटू स्मॉल सी पी माइनस कैपिटल M इंटू स्मॉल सी वी इक्वल्स टू R. तो यहाँ से क्या आ जाएगा, स्मॉल सी पी माइनस स्मॉल सी वी इक्वल्स टू कैपिटल R M डिवाइड बाई M. एंड दिस इज द आंसर, CP minus CV equals to R by M. And answer is C. Okay, I hope all of you understood. Okay, now we will move to next topic. Not next topic. One question is remaining from this topic. Okay, let's see. In this question they have given like if the ratio of specific heat capacity of gas at constant pressure to at constant volume is gamma. As we have already defined, Cp by Cv equals to gamma. I have already defined. Okay, now the change in internal energy of mass of gas when the volume changes from V to 2V at constant pressure P. Okay, one formula I derived one formula, Cp. What was the formula of Cp? Remember that formula of Cp? Cp का formula क्या था हमारे पास? Wait. First of all, we have to see what are they asking. What are they asking? They are asking change in internal energy, and that is what du. Du equal to what? We have already seen that formula, mu Cv dt or delta T. Mu Cv delta T. First we will write du equal to mu Cv dt, and then we can convert this formula into delta U equal to mu Cv delta T. Okay, and we have already defined one formula of Cv, that was Cv equals to R upon gamma minus 1. Put this Cv here, so it will become mu R delta T divided by gamma minus 1. Okay, this value of Cv हमने यहाँ ये पुट किया इधर. ठीक है, अब हम लोग जानते हैं PV equal to what? Mu RT. Differentiate both sides, so it will become PdV, and here it will become mu R dt. Constant pressure दिया हुआ है तो VdP तो become 0 हो जाएगा. See, by differentiating PV we will get PdV plus VdP, and constant pressure process दिया हुआ है तो इस वजह से ये बन जाएगा 0. Okay, so PdV equal to mu R dt, or we can say P delta V equal to what? Mu R delta T. P delta V equals to what? Mu R delta T. तो this mu R delta T वैल्यू हम लोग पुट करेंगे यहाँ पे. तो हम लोग के पास क्या आएगा? हम लोग के पास आएगा P delta V divided by gamma minus 1. Now हम लोग जानते हैं कितना वॉल्यूम चेंज हुआ है, V to 2V. That means final minus initial. Simple. So pressure, final volume 2V, initial volume V divided by gamma minus 1. So what is the answer? Answer is PV divided by gamma minus 1. PV divided by gamma minus 1. So answer is A. I hope all of you understood. Chalo.